Hello 108 students, Ms. McHugh here with you. Back on section 4.1, we're going to continue working here and we're going to cover page 2 of our class notes. Okay, now you notice I've got some green written here on the side. We're going to cover that in a minute. That's an example 3 out of the book on page 212. So that's where that came from. So I'll explain what's going on there in just a second. What I want to do here is just take a minute and I want you to think about if you draw 2 lines on a piece of paper, how many ways could you draw? Now the first way we've already talked about is if the 2 lines intersect, form a dot, that would be called a consistent solution. Excuse me, a consistent system of two linear equations, and you have one solution, the ordered pair. Now what happens if 2 lines never intersect? They would be parallel to each other. Think of railroad tracks, they never cross. That's called an inconsistent system, and there's no solutions for it, and you have 2 parallel lines. So I want you to see the connections here. 2 lines intersect, one solution. If they're parallel, no solutions. In the other cases, what if you drew 2 lines right on top of each other? That's what case 3 here is. So I'll use the dashed line to kind of illustrate that. They were exactly on top of each other. The 2 linear equations, you would have many solutions for every ordered pair that you could find, which would be an infinite amount of them. Both that x comma y ordered pairs would go into the equations and make them true. So you have many solutions because the lines overlap. Okay, so what's going on here now is we're going to tackle our first technique is to given 2 linear equations, and assuming that they have an intersection of them, we need to come up with a couple techniques or methods, and the first one's called substitution. Okay, so the substitution technique works ideally when one of the 2 equations is already isolated for the variable. Now there's some backbone to this, but flexibility, and it takes a little while to get the hang of it, and thus I'm going to show this example 3 here real quick. And so let me show you. I'm a big believer in using the method that works for you. And so this substitution method works because I look at the 2 equations, 1 and 2. Notice that equation 2 has already got one of the variables isolated. That is your key to use substitution. X equals y plus 2. Okay, this is the practical approach to it. Now I got an example down here at the bottom. The book jumps through hoops and they show you could use either method for different things. So I'll do that, but I'm strongly recommending that you use the substitution technique or when you already see one of the variables x or y already isolated. Okay, now let's just go through the steps here a little bit. You have to read them and then kind of see them illustrated here, so I'll try to work with you. Pick an equation that you can already isolate. We've already got that for this example 3. Substitute for that variable into the other. Okay, I'm going to show that here. Solve for the remaining variable. Okay, think of that right there is the first step. I don't know what I want to call this here. The first phase of your solution. First phase. Phase A is to find the first variable. Once you have a value for it, from steps 4, 5, and 6, no matter what technique, whether it's the substitution or the elimination method, which we're going to cover, you do steps 4, 5, and 6 are the same. You take the value that you found for one of your variables and you substitute it back into the original equations and you find the other or the second variable. Now it gets a little confusing, but once you have found both the x and y, that is the solution, ordered pair x comma y. Okay, so I know that sounds a little tongue-tied, but let's go ahead and try an example here. Example 3 on page 212. I try to squeeze it in up here. You can follow along in the book here to help out. I'm hoping my words will help you feel comfortable with it. Here's the 2 equations. It doesn't matter which one's written first. I look at them and I notice that x has already been isolated. It's on one side of the equation and it's got the expression y plus 2. Is everybody with me? Now the idea here is I recommend you stay organized, write your equations 1 and 2 and keep track of where you're at or you'll get confused. I'm going to take equation 1. I'm rewriting it. Okay, now I took that there and I go, do I have an expression for x? And from equation 2 the answer is yes, y plus 2. So instead of putting x, I replace it with y plus 2. Okay, that's the big substitution right there. Now once you substitute it in, how many variables do you have? 1, the variable y. Can you isolate and solve for it? Sure. Use the distributive property. You get 2y plus 4 minus y equals 6. Isolate the combine. 2y minus y gives you a positive y, and the plus 4 needs to be taken over to the other side by a minus 4 on each side, and you get y equals 2. 6 minus 4 is 2. Okay, that is steps 1, 2, and 3 that I've just done. Now that you have one of the values, what that's telling you is, real quick, somewhere on the y-axis, I'm running out of room here. Wish I could draw on a gray. Somewhere on the y-axis, let me see if I can squeeze this up here. At y equals 4, 1, 2, 3, 4, you know that's one of the ordered pairs is on. You just don't know what the x coordinate is going to be yet, so we need to find it. Okay, so now what you do is go back, pick the second equation, the other equation. It's already isolated for x. It's got the expression y plus 2. You know y has a value of 2. Substitute it in. Okay, so 2 substitute in for y. 2 plus 2 gives you 4, and x has the x coordinate of the ordered pair is 4, thus giving you the ordered pair of the solution for x comma y as 4 comma 2. Okay, I think that's a great illustration, and I recommend you use that whenever you see one of the variables isolated. Okay, now the book also shows a case here of example 4 in my class notes, and I'll walk you through this here. Over the years, I've just found out if you don't have one of them already isolated, it's just easier to use the elimination technique, which we haven't had yet. But you could study that, and I'm easygoing as to which method you use. Okay. Now from here, to use the substitution technique, you look at equations 1 and 2 and ask yourself, do you see any term where you could easily isolate the y variable? And I'm hovering over here because I see minus y. And I'm like, could I take equation 2 and isolate for a positive y? Well, if I did minus 4x on both sides, that would leave me a negative y equals minus 4x minus 1. Okay, now you need to solve for a positive y. You can either multiply by or divide by negative 1, or flip the signs of each term, and you get plus y equals 4x plus 1. Now that expression, 4x plus 1, is equivalent to y. Okay, now what we're going to do, now this step you just seen here is a precursor. I had to isolate one of the variables. I've done that. Look how I'm calling that equation 2a. Be neat, be organized. Now go back to equation 1. I wrote it down, 3x plus 2. Instead of putting y, guess what I'm going to substitute? The expression 4x plus 1. I use the parentheses, so I use the distributive property, right? Okay, so you substitute it in. That's where the substitution technique gets its name from, right there. And now you've got an algebra problem. You've got all one variable, x. Use the distributive property. You get 8x plus 2. Here's 3x, combine like terms. 11x equals, now what I did was minus 2 on both sides, and I got 11x equals negative 11. Divide by 11 on both sides, and x equals 1. Excuse me, that's a positive 11 there. X equals 1. Okay, that's the substitution technique. Now what you're going to do is steps 4, 5, and 6. It's the same, like I keep mentioning. You'll see this here in the next video. And I take the second equation, number 2, which was 4x minus y equals negative 1. Instead of putting x, I'm going to resubstitute, if you want to use that, or second substitution round of 1 for x, because I found it down here. Okay, so now you got 4 times 1 is what? 4. And we're going to subtract 4 on both sides. You get negative y equals negative 1 minus 4. Okay, and flip the signs, multiply by negative 1, and you end up with y equals 5. Okay, now don't forget, when you put your answers in here, it's the ordered pair. X was 1 from over here, from the first round of substitution, and you found y in the second round, and that's your answer. Okay, that's going to wrap up page 2, so I will see you on page 3 when we come back. Okay, goodbye.